You have to basically you split the top.
All right, your answer should be E.
Yeah. Oh, is it the
Sure. What is our rule for a P series if we just had 1 over n to the P? P needs to be greater than 1. Okay, this series is set up not as a P series, but something that you could easily do the limit comparison test to for a P series. So if we think about, like what do I tell you to do? I tell you to look at the 2 highest powers, right? And I tell you to figure out what P series to compare it to, right? So if we were to compare it to a series, we would choose 1 over n to the 1, or excuse me, we'd have to subtract 1 for this n on top, right? So 2p minus 2, right? Okay. I'm having an argument with myself. Hold on. Is this how you went about the problem? Yeah. And then you?
Yeah. Whatever value makes that greater than 1.
Okay. So 2p minus 2. Okay. I'm good. Sorry. I was having an argument with myself, but I settled it. I was putting 0 right here in my mind. But it needed to be a 1. Okay. So 2p needs to be greater than 3. P is greater than 3/2. Okay. And so then if we did the limit comparison test, we know that the powers of n would be the same, and we would get the limit to equal 1, which is positive and finite. And so as long as p is greater than 3/2, then we'd have a converging series. Does that make sense? Gabe?
I see what you did. I'm kind of having like a mental turmoil in my head about how exponents multiply together, and it's okay.
I didn't multiply exponents. I subtracted out the n on top. Basically, I brought this n to the first and moved it to this side so that we had 1 over n to the p. Okay.
Just to get really sick.
So we are going to learn the last 2 tests today, and tomorrow I will give you a nice, beautiful flow chart, because I'm also going to give you a sheet tomorrow that has all of these series on it, and you're going to have to say, which one should I use? Okay? Or today, your homework, what are you going to be looking for? You're going to be looking for the ratio test and the root test. Okay? Tomorrow you have all, however many we have, all the tests. And you're going to have to decide which ones to use. So I'll have kind of a flow chart to help you as you study for Friday's quiz. Okay? We are going to have 2 days of review. What I'll probably do is we'll answer questions, talk about things. I'll give you some work time tomorrow. And then Thursday, part of the class period will be spent me giving you a series and you doing it in class, not on your review. Okay? Because the more practice we get at deciding which test to use and going through with it, the better. Okay? So today is my favorite test. The ratio test.
Okay.
It is. Because the ratio test we actually get to use quite a bit even later on in this chapter. Okay? So the ratio test has 3 parts. First, we have a series of non-zero terms. This series converges if the limit of the ratio of a sub n plus 1 and a sub n is less than 1. Hence the name ratio test. What do you think number 2 is going to be?
If it's not that, it diverges.
Almost.
If it's
If it's
Great.
greater than 1, it diverges.
if it's 0, we have no clue.
0 is less than 1. If 0 is okay.
I don't know.
Unfortunately, my favorite test does have some potential to be inconclusive because if this ratio equals 1, we have nothing to show for it.
If it equals 1, I'm assuming there's a much easier test.
What?
If it equals 1, then I'm assuming there's a much easier test.
What, the limit test?
Well, yeah, we would have to fall back on a different test. So you would want to have a little bit of thought before you set it up to make sure it wasn't going to equal 1. Okay. So the ratio test is really good for any time you have like a crazy series. Like if you have factorials, we haven't really dealt a lot with factorials. Factorials don't work in a lot of our tests. They don't fit. You know, we have a couple tests like the geometric test and the P series where they have to fit a certain model. Okay, we can't have factorials for an integral test. Limit comparison, it's really tricky to try to, or direct comparison. Both of those, it's really tricky to try to get a factorial to work in there. If we have a combination of multiple types of things together in one series, that's going to be a clue that you should probably use the ratio test. Like if you see exponents and factorials together, use the ratio test. Okay, and that's really what we're going to work a lot with is like a combination of a lot of things. Okay, now things you're going to want to avoid would probably be like natural logs. Okay. Because looking at the ratio of the n plus 1 and the n term, natural log is not going to look real nice there.
Yeah. What if it's a negative number?
Negative is less than 1. Okay. However, it's not going to be. Why?
Absolute value.
Okay. Okay, so kind of like I mentioned before, this series has a combination of like exponents and factorials. Okay, this should scream the ratio test. Okay, because while it looks kind of crazy, the ratio test actually makes it go very nice. Okay, so for the ratio test, we need to take the limit as n approaches infinity of the absolute value of the ratio. Now, we have been working with ratios for how many years of our life?
Several.
Okay. We know that if we have a fraction divided by a fraction, it's the same thing as taking the numerator times the reciprocal of the denominator. So I'm going to just go straight to that. Okay? So we're going to take the n plus 1 term, and we're going to divide it by the nth term.
Okay, this isn't that bad.
My suggestion to you would be to group things together using the commutative property. So rearrange your multiplication here. I am going to put 2 to the n plus 1 over 2 to the n so I can see a little bit more clearly how they're going to cancel, or reduce, I should say. And then n factorial and n plus 1 factorial, I think that you should group those together so we can think about how those cancel. Now this step may not be necessary for you, but I want to give you a good visual of what's happening. Okay? If we take 2 to the n plus 1 and we divide it by 2 to the n, what do we do with exponents when we divide? We subtract. So what's left?
2.
2 to the 1. Times n factorial over n plus 1 factorial. We've been training for this our
1
whole
over
life.
n plus
1 over n plus 1. Okay? So now, as we take the limit towards infinity, we can see that 1 over n plus 1 would go to 0, and 2 times 0 is 0. 0 is less than 1, which means what? Because of the ratio test. No tricks. It's going to look like that every time. You're going to set it up as a sub n over a sub n plus 1 over a sub n. Rearrange things and simplify, and you'll get a limit that you should be able to divide with. Okay. Are you ready for another one? Depends. Okay. Now, some of us may be tempted to say that this looks geometric. However, we have that n squared thrown in there. So while it has that geometric piece, it has the n squared, which no longer makes it geometric anymore. Okay? Geometric can only be a number to the n power, or n plus 1. We can't have anything else along with it. So, like I said before, when we have a few different types of our series kind of clumped together into one, that's when I would use the ratio test. So I see something polynomial and I see something exponential. Yes?
How would you write it if there wasn't an n squared? Like, how would you simplify that into like a very easy CG?
You can't simplify.
So if we didn't have
That's what I
this,
thought, yeah.
if we didn't have this, we could write 3
Oh, you
times
put it
3
as
over 2 to the n.
Yeah, that works.
it's just a question.
Okay. So, I don't even need that. The limit as n approaches infinity. Okay, the n plus 1 term, we have n plus 1 squared times 3 to the n plus 1 over 2 to the n plus 1 times the reciprocal, because we're dividing, of a sub n. So we have 2 to the n over n squared times 3 to the n plus 1. Okay, so n plus 1 squared and n squared, there is nothing that we can do to reduce that. So we are going to have to clump those together and they just have to stay, okay? But then what happens to 2 to the n over 2 to the n plus 1?
It becomes 1/2.
And then what happens to 3 to the n plus 2 over 3 to the n plus 1? Okay, now, if this is a lot for your eyes to look at, you can do what we did over here and you can clump things together, okay? I clumped and simplified all in one step, okay? You do what works for you, all right? Well, now when we look at this limit, what happens to this limit right here? N squared blah, blah, blah over n squared. This goes to 1. Which means we have 1 times 1/2 times 3. This limit is 3/2. Well, 3/2 is bigger than 1. You need to actually tell me that. So this series diverges because can you think of a different way we could have proven that this diverged?
No.
No? Could we have used the direct comparison test and compared it to 3 to the n plus 1 over 2 to the n, that series that Gabe you asked about right at the beginning? Could we have compared it to that?
Yeah.
We could have, right? Because the series that I wrote on the board at the very beginning when Gabe had his question was divergent because of the 3 halves. And this would obviously be bigger because of the n squared in the numerator. So by the direct comparison test, we could have done the same thing. Okay? I don't know if that would have been any quicker because you have to do kind of a lot of writing with the direct comparison test. And here we just, threw together a limit with some algebra. So what's nice is you get to make that decision starting tomorrow of which test you want to use. Okay? Some of you are excited about that, some of you are not. Gabe.
Where did you get
Which 3? This 3?
I see the 3s and I see that you did some stuff, but
3 to the 1.
So there's one more 3 up here than there is here. So we get a safe one. Is that okay? Yes?
I was kind of confused because you wrote something after the 1.5.
Is it
Okay,
root
you
test
would have
time?
looked at the 3s first. Sorry.
Is it root test time?
Oh,
Are we going to go to the next one? Root.
Wait, I can't write RT because you're pretty sure you're starting the same thing.
but there's such long words to write.
I know.
There are only 4 and 5 letters ago.
Turn to your neighbor
Wait a second.
and talk through how to do this one.
Yes, you do.
I'm gonna go ahead and say
That's not for me. Yeah.
Why are we whispering?
I don't know.
Wow.
Darby and Hannah, what are your thoughts?
Who's gonna do this test?
I'm gonna pull the ratio test because that's what this lesson is about.
Okay.
Yeah.
Okay.
Wow.
Stop giggling.
You could just not do this,
Yeah, I don't think.
You could redo one day, not go to school,
Now that's flat.
What?
There's a lot going on there.
I mean, that's what I have.
What's this limit?
A big limit.
Just 1.
Wow.
I mean, I could have told you that.
Oh yeah, because it's 1 times 1. Because they both approach infinity, they both reach 1.
Could you do?
Say it louder.
We should do the root test.
God, I was like, why are we doing this?
Yeah, that's what I said.
I was like,
It's like all my training has gone to nothing. I said, what should you always do first?
Whatever
limit.
we're learning.
If the limit is not 0, don't go any
Why are you gonna
further.
bait me like that?
What if
Okay.
the limit is the absolute value of 0?
Ignore that one.
What if the limit is 0
Okay.
to infinity?
Now,
What's the absolute
Darby.
value of 0?
Yeah. Yeah.
0.
I appreciate that you asked me to do the ratio test because we got to see one that was inconclusive.
Thank you.
Okay. And we got to talk about how it probably is a good idea to think about the limit of your sequence first because you don't want to do all this work for nothing. And then you could have done less work in the beginning. Okay?
In the beginning, there was the limit.
So thank you. Thank you. We need a code word.
Limits. Radical. Because we're gonna do the root.
Forest.
A radical forest.
Ka-chow.
Okay, the root test
When you cut down the Amazon
Probably
thousands of skateboards.
involves radicals. Or
I
just
don't think
one.
I've seen a skateboard not hot. Like it's been a while.
Yeah.
Root test, very similar
But you know what's cool?
as far as how it's set up.
That was a very nice
Wow.
one.
Oh.
I like
that one.
Okay.
Yeah. What do you not like?
Does it have this?
I like that.
Does it have the same condition as the ratio test where none of the terms can be 0?
Did she not?
Morning.
Wait, that's the nth root. Wait a second.
You can start out at 0, that's fine. Right.
There's an absolute. Oh, good lord.
The nth root
Well, if it
of
wasn't
the
an
abs-
absolute value, you'd have some problems.
Yeah. I can have some problems.
What do you think the next one is?
Diverges.
Yeah.
Diverges if greater than 1. Isn't that nice that they kept it consistent for us?
Yeah.
Okay. But unfortunately, like the ratio test, inconclusive is it if it equals 1.
Wonderful.
This
So
class
they're
went by
literally-
fast. We only have 10 minutes left, people.
Only 10? I thought we had a bit more, but I guess. The nth root test. Why can't we call
Okay.
this the
Do
nth
we know
root
what to do
test?
this, man?
So the root test
It's not just the nth.
can only be used if in your series
You have a power.
your sequence is raised to the nth power.
Sad.
That's it.
It's pretty limited use.
Okay? Otherwise, our limit's not going to work out
Oh,
very
because
well.
limit like cancels out. So it's like a more broad version of the geometric series.
I'm not gonna remember how to do geometric series at the end of this semester.
Oof. Well, that's only in a couple months.
How many of you are taking the AP test?
Wow.
I asked that question in my AV class, and 2 people raised their hand. And I
Wow.
have 28 people in there. I was like,
They have to take a test anyway for their final.
Yeah.
I didn't take it last year.
I'm gonna-
You're a fool.
I'm going to work on it. I'm going to work on it. All right, write this one down.
Why am I a fool?
When you said no, about
We have 3 examples. 3 examples.
I don't know if we can do 3.
That's why you're a fool.
Gabe, what if Jack Black was here?
Oh.
What if Jack Black was here?
Okay, so
Wow, look what you've done. Thank you.
No, it's my man Horatio.
Oh yes. She was the first.
if we reorganize this, we can see that this is e squared over n to the n power. This is a problem if we did not know the ratio, or excuse me, the root test, because while this looks geometric, there's an n inside, right? We don't know if our r is less than 1 or greater than 1 because it's n, all right? So our only option is the root test. So we'll take the limit as n approaches infinity of the nth root of e squared over n to the n power, okay? Because we have an n power and an nth root,
Cancels.
they kindly cancel out. And we're left with e squared over n.
Oh, and look, it equals 0.
Okay. We have a constant over n. That limit is 0, which is less than 1. So this series converges.
What if you still manage to
By
get
the
a
root
negative
test.
number? Is I less than 1?
Freaking magic. That's how.
Well, there's an
Is
absolute-
I less
there's an
than
absolute value.
Yeah, what
There's
if,
an absolute value.
what if you're such
There's
a,
an absolute value.
What if
End
you're
of
so-
conversation.
What if you're so good
Nope.
that you can
I
get a
think
negative out of
Joe's
an
favorite
absolute?
phrase is
Questions.
what if.
Yeah.
Yes.
Could
What
you also use the direct comparison test with a geometric series? Because, like, if you compared it to, like, 0.99 to the n, then that would be less than it for everything greater, for where n's greater than, like, 8.
That's quite a.
What?
Because that's what the book did for, or what Calc did for, like, the, like 1 over n factorial. They used the direct comparison test and compared it to n squared. 1 over n squared.
Because after 2, it's bigger.
Yeah.
But this is convergent, so we would want it to be less.
Yeah.
Is that what you said?
Yeah.
That's how I'm going to create a jump force. Jump force. Goes on for
And that would be pretty creative, but as long as you can convince
Yeah.
me that.
Yeah.
Jump
Yeah.
force is basically Naruto versus
Okay.
Goku.
Yeah. What's nice about the
It's literally-
root test is, you
Yeah,
know, the
it's a
ends
lot
cancel
easier.
out and boom, we're done.
Yeah.
Yeah, but yeah, you're right. That would work.
Okay.
You're thinking very creatively with
Yeah.
your tests. I would like to point out. I actually had to consult my husband on your quiz.
Oh no. What did I do that was weird?
What did I do to
You're
deserve
Any of that
this?
quiz.
You're the first person that has ever done what you did on the quiz. Write this one down.
It diverges. I can move it tonight.
What you did was legal,
Okay.
but I had an argument with him.
Police arrest. You were
The
drunk
math police,
driving.
they're a real thing. Like, I die a little bit inside every
Yeah,
time
it's just the limit test.
this
Get
happens.
rid of the end power. This is just the limit test, but you use a root to get rid of the end power.
Okay, so
I'd end up being that kid who writes it converges to 3 over 2, by the way. That's gonna make me on the test. It's gonna happen. Multiple
Okay.
times.
the nth term test only tells us if it diverges. I need to make that very clear.
Yeah.
Okay. Now, without this, you're right. It would be divergent. But it is to the nth power. And in order to take the limit of this guy for the nth term test, we would have to use L'Hopital's rule, which I don't feel like is worth our time if we have the root test. So with the root test, since we have an nth power, we can throw it under the nth root, and they cancel. So then we're just looking at the limit as n approaches infinity of 3n plus 4 over 2n,
How would you look?
Wow.
which is 3 halves.
I think that rises.
Greater than 1. So we have a divergent series because of the root test. But a couple of you saw that right away. I know that if I use the nth root, those are going to cancel. I have 3 halves for my limit. Our brains sometimes process it faster than we have to write it all down. But make sure you don't skip any steps and that you give me the reasoning for what's happening. Okay, one more example. You ready?
The only church.
I need like this speech to text dictation. That's what
Can you imagine having to do math like that? Like,
Oh.
in real
One
life?
plus sign. One
Because it's just
root
banjo
sign.
with a rope.
It's not me that
Sigma superscript.
This is gonna be more
It's
needed.
inconclusive.
Yeah.
Okay.
Isn't that just
Okay, so you can tell that this is going to be inconclusive from the root
Why are the
test,
examples so
right?
easy?
Because the nth root and the nth power would cancel out, and the limit of what's inside would equal 1. That would be inconclusive.
Can you just make our whole test like root tests in P series? Like that would be
However, if we take the limit of our sequence, it equals e, which doesn't equal 0, so we diverge
So yeah, just don't use the root test.
because of the nth term.
They were in the
I
same
feel like
order
that's been in
too.
every lesson where it's like we learned a bunch of stuff and then there's the E limit and then it's like, oh, that's just after every
I'm trying to like ingrain it in your brain that that is e. We've done the limit enough times to where you can just know that it's e. It's fun. Okay. All right. So you have a homework assignment to practice these 2 tests. Okay.
Oh yeah.
And then tomorrow we'll look at all the differences. Woo!
And then ironically we take a quiz.
Ironically, what?
We take a